Welcome to our last session of today. And first we will have Nahmgoong from KIAS talking about 60 superconformal Cardy formula.
Thank you very much for the introduction. My name is Nahmgoong from the Korean Institute for Advanced Studies. Today, I would like to talk about the 6-dimensional superconformal Cardy formula, which is based on my recent paper loaded in this July. So, let me begin my talk by briefly introducing the Cardy formula. The Cardy formula determines the asymptotic free energy of the radially quantized conformal field theory in the limit called the Cardy limit. Here, the Cardy limit refers to the limit where the spatial angular momentum is much larger than the common central charges of the CFT. It was originally found in two-dimensional CFT by Cardy, and there has been much progress on recently there has been much progress on the 3, 4, and 5-dimensional Cardy formulas based on the suburb known as the superconformal indices. The importance of those high-dimensional Cardy formulas is that by performing the Legendre transformation of those high-dimensional Cardy formula, we could precisely obtain the entropy of certain BPS black holes in the dual anti-de Sitter spacetime. So in the similar logic, in this talk, I would like to focus on the Cardy formula of 6-dimensional superconformal field theories. In 6-dimensional, there are some, in 6-dimensional conformal theories, there are SO2, conformal symmetry, and for 1,0 supersymmetry, there are SU2 symmetry. And furthermore, there can be some possibly more flavor symmetries, but for simplicity, we will ignore this kind of flavor symmetry and only consider this SO6 conformal symmetry and SU2 symmetry. Then with these global symmetries, we can redefine the superconformal index in the following modified basis. Here, this I is the superconformal index, which depends on the chemical potential. We take a trace over the Hilbert space, and we insert the BPS regulator, which counts only BPS factors. And there is a SU2 R-charge factor, and also SO6 angular momentum factor, which is inside this conformal algebra. So here, in this manner, the delta and omega, the chemical potentials are constrained by the supersymmetry, and in this case, delta and omega should satisfy this linear relation to preserve the supersymmetry. In this case, this unusual 2 pi r shift of the relation plays a critical role because this 2 pi r shift exactly realizes a boson-fermion cancellation inside this trace. Therefore, without the explicit minus 20 insertion, this definition exactly plays the same role with the superconformal indices. In this setting, the Cardy limit refers to the limit where omega, the angular momentum chemical potential, is much smaller than 1. Because if we take the Legendre transformation and go to the microcanonical ensemble, it corresponds to the limit where the 3 angular momenta are much larger than the n cube, which is the common scaling of the central charge, 60 central charges. So the goal of my talk is to compute the superconformal index in the Cardy limit by using the background field analysis. So I will briefly explain what is the background field analysis. So I will compute the superconformal indexes in the Cardy limit without using localization. We consider the radially quantized CFT. So the index can be computed from the Euclidean sixth theory known as 5 times S1. We are using the fact that the index does not depend on the regulator beta, so we will turn it off to 0. In this case, the radius of the circle, Euclidean time circle, shrinks down, and we can effectively integrate out all the heavy color supply modes on the circle. And as a result, we obtain some effective action of the background fields on the phi sphere. So there are two types of the background fields. The first one is the background metric G mu nu, and it depends on the angular momentum chemical potential omega 1, 2, and 3. And the other one is the background gauge field A for the SU2 R symmetry, and it depends on the R symmetry chemical potential delta. As a result, the superconformal index can be written in terms of the effective action as follows. This is the effective action comes from the heavy color supply modes, and plus some possible zero mode contributions. And in this section, I want to focus on the structure of this effective action. The critical fact about the effective action is that if we take a background gauge or background diffeomorphism variation of this effective action, it is non-zero. The background variation of the effective action is non-zero because of the presence of the drift anomaly in 60. As a result, the structure of this drift anomaly can constrain the structure of this effective action. So basically in the effective action, there are infinitely many terms arranged in the derivative expansion. Among those infinitely many terms, the 5D Chern-Simons terms can be fully determined from the 60 anomaly polynomial. It was first proven in terms of the hydrodynamic context by using some CPT invariance of those Chern-Simons terms and imposing some consistency condition with the Euclidean vacuum. Also, of course, without those Chern-Simons terms, there are some non-Chern-Simons terms in the effective action, and also some zero-mode contribution. However, we show that they are summating in the Cardy limit free energy. So let me show you some explicit examples. Let us consider 62,0 CFT. It is well known that 62,0 theories have a well-known AD classification. It has the global symmetries that it has is SO5 R symmetry, and also SO6 diffeomorphism, which is isometry on S5. So basically, using the anomaly polynomial of this R symmetry and diffeomorphism, you can construct the Chern-Simons terms of these global symmetries, the background field of these global symmetries. So this is the structure of the complete structure of the Chern-Simons terms. And all we have to do is to evaluate those Chern-Simons terms on the S5. So let's back to our result. Then we have to introduce some Kempe potentials which correspond to the global symmetries. And there is a delta 1 and 2 for R charge, and omega 1 to 3 for angular momentum Kempe potentials, which is constrained by this relation to preserve the supersymmetry. So by evaluating the Chern-Simons terms, which I show in this page, we can obtain the Cardy free energy, which is a log of the superconformal index in the Cardy limit as follows. So this is the result that I obtained. And as you can see, each coefficient can be represented in terms of the group derivative coefficient. For example, here H is the dual positive number, B is the dimension, and R is the rank of this Lie algebra G. Also, this free energy is expanded in terms of the small omega up to the log omega fractions, which cannot be determined from the Chern-Simons action. The importance of this free energy is that it's directly related to the entropy of BPS black holes in the ADS7. So let us consider the large n limit of AN or DN type theories. Then we can see that among these free energies, this first term becomes the leading term in the larger limit because this first term has the coefficient which is proportional to the NQ in the larger limit. If we perform the Legendre transformation of this free energy, we precisely obtain the entropy of the BPS black holes in the dual ADS7 spacetime, where the Newton constant is inversely proportional to the NQ. So now let us move on to 61,0 theories. There are many 61,0 CFTs, but here I'll just show the universal structure. 61,0 theories can have SU2R symmetry and SO6 diffeomorphism symmetry, and we will ignore the flavor symmetry. And in this case, the anomaly polynomial A form can be generally written in this manner. Your C2 is the trunk class of this R symmetry, and P1 and P2, they are the punctuating classes of the diffeomorphism symmetry. So the general form of the anomaly polynomial can be written as follows. Here A, B, C, and D, they are the four coefficients which parameterizes the anomaly polynomial. And as you can see, A is the coefficient of the pure R symmetry anomaly, B is the mixed anomaly, and C and D, they are pure gravitation anomaly. So by using this anomaly polynomial, you can write down the Cardy free energy as follows. As we can see, in each term, the coefficients can be fully determined from the Tooth anomaly coefficients. The implication of this free energy is that this Cardy formula can impose a non-trivial bound on the anomaly coefficients, on the Tooth anomaly coefficients. So let us perform the Legendre transformation of this free energy. If we Legendre transform of the free energy, we obtain the entropy, which is asymptotic entropy in the Cardy limit. if we consider the real part of the obtained entropy, it takes the following form. There's a leading term. It has some positive number times a certain linear combination of the anomaly coefficients, which is given as A minus 4B plus 16C. Since the entropy is the log of the number of the microstates, we can generally expect that real part of the entropy should be non-negative. As a result, if we impose the real S to be non-negative, we obtain the following entropy bound that A minus 4B plus 16C should be equal or larger than 0. We expect that this inequality should satisfy all 60 SCFPs. We checked for various examples and currently found no concrete examples. And interestingly, the same combination has been also observed in terms of the supersymmetric Rayleigh entropy of the 60 superconformal theories. So, let me conclude my talk with some concluding remarks. Our background field analysis can be checked by matching with the known results. For example, there are some superconformal indices whose closed forms are known. In that cases, we can explicitly compute the Cardy free energy, and the obtained Cardy free energy from the closed form exactly match with the background field analysis, which is introduced in this slide. And also, our background field analysis is only a chiral anomaly, and therefore it can be applied to 40 theories. And it also matches with the 40 NT1 Cardy formulas, which is derived in the different manner. And lastly, we can consider 60 theory on the alpha times T2, and again perform the background field analysis on the alpha times T2 by shrinking one circle inside the torus. Simultaneously, the supersymmetric indices on alpha times T2 can be computed from the elliptic genus of the self-field strings, which is wrapping on this torus, and we show that the two results exactly match. And this is what I'm working on currently. In conclusion, we show that the Cardy limit of the superconformal indexes can be determined from the Tufte anomaly of the 60 theories. And also, our Cardy free energies related counts the spectral part, and it's without the Casimir energy. Also, in the larger limit, it explicitly depends on the n cube, which precisely determines which precisely reproduces the entropy of the VPS black holes in the area 7. And this is it, and thank you for listening.
Any questions, comments?
I saw your entropy. There is factor square root 2.
This one?
Yeah.
Yes.
Since all the anomaly are rational numbers, why is square root 2?
Because here we have a real part of the omega.
Yes.
But actually, in this Cardy limit, omega has a real part and imaginary part, which is the same order, the same value. So the square root of the real part omega is just the absolute value of omega. So, yeah. There's no irrational number in that sense.
More questions and comments?
Okay, then one comment. So there's an ambiguity, right, for the Suzy condition up to 4 pi I.
Right.
Which may give effect on this log I.
Yes.
Right. Can you fix this ambiguity?
Well, that's the critical point, because this 4 pi I shift is related to the periodicity of this delta. But in this anomaly, in this background field analysis, it is insensitive to the periodicity. And we have to specify some valid chamber that this expression is valid.
So you could fix this ambiguity, I mean.
Yeah.
You can do.
More questions? If not, let's. Oh,
Maybe
yeah.
one
Go
more
ahead.
comment. So this coincidence of this piece with the super Rayleigh entropy actually happen in any dimensions. X percentage.
At least in, actually I checked in 60. For me, I have only checked in 60. But we expect that it can be matched with same other dimensions.
Okay, if no more questions, let's enjoy with